Chapter 2, paragraph 3 is about water as a solvent. Water as a solvent. Last chapter, chapter 1, we talked about matter and how you can divide matter into pure substance and mixture. Where a pure substance is only one molecule and a mixture is more different kinds of molecules. So the pure substance is the thing we're going to leave for now. We already did that one. And we're going to continue on the mixtures. And there are basically 3 different kinds of mixtures that you should know. I'm just going to write it here under the pure substance, otherwise it won't fit. And there is the solution. There is suspension. And there is one that we're going to leave for now, emulsion. This one will come back in paragraph 5. So we're just going to leave that one for now. Now we're going to only talk about solution and suspension. Solution is a mixture of either a solid and liquid, or liquid and liquid. Liquid and liquid. And basically the main property of a solution is that it is always clear, which means that it is transparent. That is that you can actually see through. It can be colored, however, so it can have a color. Like tea, for example, it is clear because I can see through it, but it does have a color, namely a bit brownish, reddish, greenish, depending on the tea. So it can have a color, but you can actually see through it. A suspension is a mixture of a solid and a liquid. So, example given. This is like sugar and water, alcohol and water, but also tea is an example of a solution. A suspension is solid and liquid, and this is turbid, which means you cannot see through it. It is non-transparent, which is what they call opaque, which you probably never heard of, but now you have. So it's turbid, opaque, or basically just non-transparent, or you just cannot see through it. That is because this solid doesn't dissolve. And there are a lot of examples for those. Like, for example, orange juice. Or sand and water. The two of them, they don't mix, so it is a turbid suspension, a turbid substance. You cannot see through it. Okay, so we're going to leave the emulsion for later. If you have a solution, if a substance dissolves, you can calculate the solubility. Sorry, you already knew my writing is bad, right? And the solubility of a substance is the max gram in 1 kilogram of solvent. Solvent is where you actually dissolve it in. Mostly water. It can also be alcohol sometimes, but it's mostly water, sorry. So for example, the solubility of sodium chloride, which is table salt, is 359 grams per kilogram. That means when I have 1 kilogram of water, I can dissolve 359 grams of table salt. Now, for example, I have 20 grams table salt. How much water do I need? To answer questions like this, it is very useful to use a ratio table. You might have seen it in math. Well, and if not, then you will see it now for the first time. I have salt. I have water. I know my ratio because I know I have 359 grams of salt in 1 kilogram. I know I have 20 grams of this one. So I have 20 grams of salt, and now I want to know this one, so I'm going to write down a question mark. In a ratio table, you should make a cross over here. So I have this one, and I multiply it by that one, I divide it by that one, and I end up in here. So that is why in Dutch we also call it a cross table. In English, that's not actually what you use, but hey, it does make sense. So I'm just going to cross, so I do 20 times 1, so I'm going to calculate 20 times 1, divided by that one. And then it is very, very useful to have a real calculator. So you may use your phone if you want to, but I strongly advise you to take a real calculator. So 20 times 1 divided by 359 equals 0.05. kilogram. As you can see, 0.6. Equals 56 grams, which is about like 50 milliliters. So these ratio tables are very useful if you're going to calculate on solubility.